What's up, Sigmas? This video is to build a model for velocity versus time graph for you to use in equations. This is a very skibbity topic, so be sure to listen. Skibbity, riz, no.
Alright, so this video is going to show you how you can use Desmos to build a velocity versus time graph. And I'm going to show you how you can use calculus notation, and it will give you the area under the curve. So remember, the area under the curve is going to be your displacement. Your final y-coordinate is going to give you your final velocity. Your starting y-coordinate is going to give your initial velocity, and your acceleration is going to be the slope. All right, so what we want to do is we want to come up with an equation that has our final velocity as a function of our time. I'm going to start with our acceleration equation. And what I'm going to do is I'm going to rearrange this equation to get my final velocity by itself. And I'm going to form an equation where it will have my final velocity as a function of my time. All right, so I'm going to multiply both sides by time. Now my times are going to cancel out. And then I'm going to add my initial velocity to both sides of my equation. When I do that, I will have that my final velocity is equal to my acceleration multiplied with my time plus my initial velocity. This will be the equation that I used right here. Now, when we put it into Desmos, we want to show that the variable that is going to be my output, so that y-coordinate is going to be my final velocity. And then when we put parentheses, that's saying it's a function, so my x-coordinate, the thing that is being changed, my independent variable is time, and my dependent is going to be my final velocity. We're going to write it out on Desmos just like you see here, plus my v initial. And then we want to restrict our domain. So we want to restrict the amount of times that we're going to use. And we're going to make that a sliding bar. So we're going to add into the side that our lowest possible time that we could have is 0. And our time needs to be greater than or equal to 0. And less than or equal to whatever we're going to put as our time when we're actually plugging stuff in. Some other notation that you need to use is we're going to use this integral notation. When we type in int onto Desmos, it's going to give us our integral symbol. We're going to have our starting time down here and our final time down up here. So we're going to go 0 to time final. And then we're going to have our equation. So we're going to have our expression right here. And that is going to be based on time being our independent variable. Okay, so what we want to do is we're going to come over to Desmos. We're going to write out the equation that I just showed you. So we're going to have our final velocity as a function of our time. It's going to be equal to acceleration multiplied with time plus our initial velocity. And then this is going to be from the times of 0, time final. So that'll give us a slider. And then I'm going to put, no, we don't want to put time final right there. We want to put t, and then this is going to be time final. Okay, so this gives me the options to add acceleration, initial time, and my final time. I want to add all of these sliders. And if my initial velocity is 0, actually I want to change these. I want to say that the velocity values that I want to get is going to be between 0 and 100. I want them to move 1 meter per second each time I slide that bar. My acceleration, I'm going to go 0. Okay, my acceleration, I want it to be from 0 to about 10. And again, I want these to slide up by 1 every single time. My time, I want it to go from 0 to about 30. You can change these later if you need a different time, and then we will put steps of 1. Okay, so what we did was we modeled our velocity. So this is a velocity versus time graph. I'm going to put my label for my x-axis here. We go up to this wrench. We go over to label for our x-axis. I'm going to put time in seconds. My y-axis is going to be velocity in meters per second. Now we have a model of our velocity versus time graph. Now the important thing that we want to do here is we want to get the area under the curve. And we do this by making an integral for our expression right here. So I'm going to put int for integral. My lowest time is going to be 0. My maximum time is going to be this final time. And then I am going to write out my expression. So I have at plus my initial time. My independent variable is going to be time. Now this will give me my area under the curve for any time span that I want, for any velocity that I want, and any acceleration. So if I look, I could actually change this graph and it will adjust accordingly here. This is my displacement. I have my final velocity is going to be located at the top of my function. One last thing that I want to do is I'm going to make it so this last point is actually a point on my graph. The way that I do that is I'm going to start parentheses. I'm going to put my x coordinate and my y coordinate for that last point on this function right here. My x coordinate is going to be my final time, so time final. And my y coordinate is going to be my final velocity, so v final, when my time is time final. And I want to make sure that this is selected where I have the less than or equal to. And now what I want to do is I want to label it, and that'll show me what my final velocity is at all times. And now what you can do is you can use this model to solve for all kinds of those motion equations that you guys will be dealing with in this class.